Hey everyone, so this is our last new graphing rational functions lesson. Today we are going to focus on problems where the degree in the numerator is greater than the degree in the denominator. Pause the video and find the domain and range of these functions below. Alright, so I'm always thinking about these in terms of vertical asymptotes and horizontal asymptotes. So my vertical asymptote is where the denominator equals 0, x equals -1. And then my horizontal asymptote is at 3 minus 1, which is 2. So those are telling me my domain and range. So my domain is all real numbers except x equals -1. My range is all real numbers except y equals 2. And that's it. Now this one, notice they are factorable on the top and the bottom, so I need to do that. So x plus 7, x minus 7 on top. And then on the bottom I have x. I knew I made a mistake. It's supposed to be x plus 7, x minus 4, x minus 3. That's supposed to be a 4. You know, when I wrote the problem, I'm like, oh, I did it right, and then I thought it was off. All right. So that means the reason we're doing this is because this will have an effect on the domain and range. So those cancel, but -7 is still not part of the domain. So my domain is all real numbers except x equals 3 and x equals -7. Here's why we need to know this, though, because there's going to be a hole in the graph. The range, we have all real numbers except our horizontal asymptote is 1 plus 4, which equals 5. Right? Divide my x's plus the 4. So y equals 5. But also remember that we have a hole in the graph at -7. So I need to plug in -7 into my simplified fraction. So that gives me -14 over -10 plus 4. So what's that? 7 over 5. So that's 1 2/5. So 5 2/5. So I need to find that other y value that there is a hole. So remember, this thing has this weird hole at -7 and 1 2/5. So the graph looks like 3, 5, and then it has that like weird hole in there. So the graph would look like that. Okay. All right. What if a rational function does not have a horizontal asymptote since the numerator has a higher degree than the denominator? So if we try to find the horizontal asymptote, we look at our x's and we get x squared over x. Well, that's not going to 0. That's not going to any number. That's going to infinity, right? If I plug in a really, really big number, I'm just going to get a really, really big number. So what we need to do is we need to divide. We're going to use long division. You could use synthetic. I usually use long division for these, just out of habit. So what happens is, if I divide, I get x into x squared is x, multiply, change the sign to subtract, 3x plus 4. So that gives me plus 3. 3x minus 9. Again, change that sign, and I get 13. So this function is actually being rewritten as x plus 3 plus 13 over x minus 3. This is just a rewriting of the function. So instead of having a horizontal asymptote, this has what's called a oblique or skew There's another word for it. It's on the next page. I can't remember. This is going to have a diagonal asymptote at the point on the line y equals x plus 3. So y equals x plus 3 is an asymptote. Okay? So we do long division and rewrite the function, or synthetic division if you can. Rewrite the function just like we did when we divided. Whatever that, you'll get this linear function in front. That is an asymptote. All right, slant, that's what it's called. I always want to say skew. Slant. Okay, so rewrite the function using long division. I can spell. The linear function that you get, the linear term in front of the rational part, in front of the fraction, I'll just put fraction, is the slant asymptote. Okay? All right. Before we go to the next page, I want you to draw a stick person. Draw a stick person on your paper. I'm going to look for that stick person. All right, so pause the video. Do some long division to rewrite this function. So negative 3x squared plus 2 divided by x minus 1. Good job leaving space there, Ms. Fazone. All right, negative 3x squared plus 3x. If you're lost as to what I'm doing, look in your notes or Google long division. Change the sign. So this becomes a plus, this becomes a minus. So I get negative 3x plus 2 minus 3 minus 3x plus 3. Change the sign. This becomes plus, this becomes minus. So our new function is y equals negative 3x minus 3 minus 1 over x minus 1. That is my function. Right? So I have a vertical asymptote at x equals 1, just like before, but I do not have a horizontal asymptote. There's no horizontal. There is now a slant. We have our slant asymptote at y equals negative 3x minus 3. So I'm going to start by graphing the x equals 1. So there's my x equals 1. And then I'm going to graph, sorry for the weird pause, negative 3x minus 3, right, this line. So minus 3 is my y-intercept. My slope is negative 3. So that's up and left. I had to fix this video because someone pointed out that I forgot how to graph a line and had the slope wrong. All right. So there it is. So now I need to figure out where is my region. There are 4 spots here. So let's pick some points. So I like to plug in 0 a lot of the time. So if I plug in 0, I get, let's see, negative 3 minus 1 over negative 1. So that's negative 3 plus 1, so negative 2. So that's like right above it, which means this graph is going to be like this. I'm pretty sure. We can plug in like negative 1 also, or 0.5 to check that. I'm going to plug in 2. Let's see what happens when I plug in 2. So that's negative 9 minus 1 over 1, right? 2 minus 1. So that's negative 10. So 2, negative 10 is right here. Yeah, so this is also like this awkward graph in the middle there. So this is kind of a weird one. It's a little awkward looking, but it is what it is. All right, pause the video. See if you can do this on your own. So we're going to start by dividing x minus 2 into x squared plus 3x plus 2. So x squared minus 2x, 5x plus 2, 5x minus 10, 12. So my function is x plus 5 plus 12 over x minus 2, which means my vertical asymptote is x equals 2. My slant asymptote is y equals x plus 5. All right. Whatever's in front is my slant asymptote. All right, so I'm going to draw these. I'm going to use my highlighter this time. All right, so I have x equals 2. And x plus 5. 1, 2, 3, 4, 5. All right, so let's see. So again, really I'm just plugging in to see where my regions are going to be. I know this thing is going to get close, like it's probably like something like that. I'm not really sure though. So I'm going to plug in points to see where these regions end up being. So let's plug in 0. 0 is an easy one to plug in. So if I plug in 0, I get 5 plus 12 over negative 2. So 5 minus 6 is negative 1. So 0, negative 1. Really? Let's just check. Yeah, that's right. That's interesting. All right, so let's plug in. I'm going to plug in 1. See what happens there. So I get 6 plus negative 12. So that's negative 6. 1, negative 6. Okay. So my guess is this thing's going to go up and then back over like that. All right, so now let's plug in 3. If I plug in 3, I get 8 plus 12. Ooh, 20. That's 320. Ooh, so that means this one is going to be up like this. So it's really crazy off the graph. It's going to be up there because 320 is like up. We're in this high spot over here. So that is going to be my... this one we're not going to get as crazy with the points because it's too hard otherwise. All right. So that's what this one looks like. All right, so last problem. This is the hard one. Pause the video, do your long division, rewrite the problem. All right, so I'm going to do 3 minus x squared into 2x cubed plus 4x squared minus 9. Now, notice you have to do long division for this one. You're not able to use synthetic for this if you have been using synthetic. I don't like that this is written 3 minus x squared, so I'm actually going to erase this and reverse it. I'm going to make it negative x squared plus 3. All right, so negative x squared goes into 2x cubed negative 2x, because that gives me 2x cubed minus 6x. I'm going to change the sign. That becomes a plus. We end up with 4x squared plus 6x minus 9. And then we have minus 4. So that's minus 4x squared minus 12. Change the sign. Thank you, Sierra, for emailing me that I made another silly mistake. All right, so my new function is negative 2x minus 4 plus 6x plus 3 over 3 minus x squared. So this is the new function. So I now have it written where it's not like an improper, imagine it's like an improper fraction, right? The higher power is on top. That we didn't want that to happen here. All right, so now I'm going to find my vertical asymptote, horizontal. There is no horizontal, right? My vertical asymptote is x equals plus or minus root 3. All right, that's not factorable. So that's like 1 and change. So it's like 1.7, I'm pretty sure. So we have that vertical and this vertical. And then I'm going to graph the line, negative 2x minus 4. So 1, 2, 3, 4, with a slope of negative 2. These are complicated. If you're like, oh crap, Miss Fazone, this is rough, I agree with you. This is rough. All right, so now we need some points to figure out where these graphs are. I'm going to plug in 2. Let's start with 2. All right, if I plug in 2, I get negative 8 plus 12, 15 over negative 1. Negative 8 minus 15, so negative 23. All right, so 2, negative 23. So again, I'm kind of in this weird region, so the graph is going to end up looking like this. I'm going to plug in 0. See what happens if I plug in 0. I get negative 4 plus 3 over 3 plus 1, negative 3. 0, negative 3. So right there. I wonder what's... I'm going to plug in 1 to see what I get there. So it's negative 6 plus 9 over 2. Negative 6 plus 4.5. That's negative 1.5. So 1.5. Okay. So it looks like, so I'm staying here. I'm wondering if this is going to cross through or not, though. Let's plug in negative 1. Ugh, I'm running out of space. All right, negative 1. Let's see. That's negative 2 plus negative 12 plus 3 is negative 9 over 2. Negative 2 minus 4.5, negative 6.5. Negative 6.5. So negative 1. Okay, so this one's actually crossing through the asymptote. So notice it crossed through the asymptote, which happens sometimes. Okay. And then I'm going to plug in negative 3. Finally, negative 3 to figure out that last region. I have a guess. Let's see if I'm right. So we get 6 minus 4 is 2. Plus negative 18 plus 3 is negative 15 over negative, no, it's going to be positive. Nope, negative 9, 6. So 2 plus 2 and a half. So 4 and a half. So negative 3. 1, 2, 3, 1, 2, 3, 4 and a half. So that's what I was expecting. I had a feeling it was going to be in here. All right, so notice we do have this graph where that's why we can't say with asymptotes it always doesn't cross it. Sometimes it does. This is a case where it did cross over our slant asymptote. All right, that's it. I will talk to you guys tomorrow. Bye. All right, working this homework. I know this is hard. We're going to do some practice days. There's no more lessons, but practice days. All right, I'll talk to you guys later. Bye.